Today our aim is to simplify complex expressions. We're going to take a break from solving equations and work on simplifying expressions. Now, what does it mean if they're complex? Complex means they're dealing with complex numbers. A complex number is a number in the form a plus bi, where I is the imaginary number square root of -1. I, like pi, is a number, but we treat I like a variable. So we're not solving equations today. Again, we're simplifying, and when we are done simplifying or cleaning up, our final answers will always take this form, a plus bi. Tomorrow you'll see where complex numbers come from, but today we're just going to get comfortable working with them. Take a look at example 1. Here we have two complex numbers. It looks like they've got components of a plus bi sort of in the wrong order, and we're subtracting them. So we treat I like a variable even though it's a number. Treat I just like it were x. So all we need to do is distribute the subtraction sign. So we're subtracting 2i, we're subtracting -1, we're adding 1. At this point, we're going to combine like terms, meaning we've got two real numbers, two imaginary numbers here. When we combine them, we have 4i minus 2i would be 2i, 5 plus 1 would be 6, and now we're going to put this real number first. So we have 6 plus 2i. This is our a plus bi format. Because it's in the format a plus bi, we know we're done simplifying. Okay, next example. Here we're no longer subtracting two complex numbers, we're multiplying two complex numbers. So we're going to use the box method. Again, I is a number. I is the square root of -1, but we treat I as though it were x, a variable. So we're going to use the box method to multiply. We're going to combine our like terms. So we have 8i squared plus 6i minus 5. We're not done because it does not yet have the form a plus bi. Well, what's different? This 8i squared business. It doesn't look like an a, it doesn't look like a bi at this point. So how do we deal with that? Well, I know that I is the square root of -1. So this is 8 times I squared. The 8's not being squared, just the I is. Plus 6i minus 5, we'll deal with those later. And we know that taking a square root and squaring are inverse operations, so they undo each other or cancel each other out. So we're left with 8 times -1 plus 6i minus 5, or -8 plus 6i minus 5. Again, combining like terms, we have -13 plus 6i, and we're done simplifying because our expression has this form, a plus bi. Okay, next example. Simplify the expression 4i times the quantity 2i minus 1. Again, I is a number. It's the square root of -1, but we treat it like a variable, so we can just distribute. We're not done because it's not in the form a plus bi. This element right here is different from that form a plus bi, so we can substitute. I is the square root of -1. We know square root and square cancel each other out. They're inverse operations. We put it in a plus bi format, and we're done simplifying. Okay, let's take a look at example 4. This example has I to really high powers. But again, to get started, we can think about simply distributing the term on the outside of the parentheses. So we would have, remember, if you have x squared times x cubed, that means x times x times x times x times x, which gives you x to the 5th. Oh, right. To multiply bases, we add the exponents. So this would give me 8, 4 times 2, I to the 23rd power. 16 plus 7 is 23rd, minus 36, I to the 38th power. Well, this is definitely not an a plus bi format because I have a whole bunch of i's over here in each term. Okay, well, we know we can substitute. I is just the square root of -1. So essentially, we have 8 times the square root of negative 1, and we're going to multiply the square root of negative 1 times itself 23 times, minus 36 times the square root of negative 1 to the 38th power. Well, the square root of negative 1 was easy to deal with when we had pairs. So we can think about this as 8 times the square root of negative 1 squared times the square root of negative 1 squared times the square root of negative 1 squared. Okay, I'm thinking about this number 23. 23 is 22 plus 1, and that's helpful to think of 11 pairs with 1 left over, right? 23 is odd, so that's why you get that 1 left over. So if we keep multiplying, here would be my 11 pairs, right? I'm writing each one as though it's being squared. Here's a pair, here's a pair, here's a pair, right? We have 11 pairs and then 1 left over. That's not being paired. Okay, minus 36. Now here, square root of negative 1 squared, square root of negative 1 squared, right? We're multiplying the square root of negative 1 by itself 38 times. Well, 38 is an even number, so all of those values can be paired up. 38 is 19 pairs. So we would have the square root of negative 1 squared, 19 of those pairs. I know this is messy, I promise it's going to get neat. Okay, so we have 8 times, well, look at this. Square root and square cancel each other out. Square root and square cancel each other out. Again, these are all canceling each other out, so we're left with 11 negative 1s. So 8 times negative 1 times negative 1 times negative 1. We have 11 of those negative 1s. Plus, don't forget about this leftover guy. Square root of negative 1. It was a single. It was not a pair, so the square root didn't have anything to cancel out with. So we have minus 36. Again, we're going to cancel out a whole bunch of square roots and squares. Here, there's no leftover 1. Since 38 was an even number, there was no plus a leftover. So here we're going to end up with 19 negative 1s, since we had 19 pairs. Okay, it's about to get cleaner. We have 8 times, well, negative 1 times negative 1 times negative 1 times negative 1. If you were to multiply a negative number 11 times, you would get a negative number. So we have 8 times negative 1 times this leftover square root of negative 1 minus 36. Again, if you're multiplying a negative 1 by itself an odd number of times, you end up with a negative number. So we have negative 8 square root of negative 1 plus 36. A negative times a negative made that positive. We're almost done. It almost looks like a plus bi. But we've got this weird square root of negative 1. We're going to substitute back. So this is negative 8i plus 36. Put the real number first. And here's our final simplified expression. This was tricky, so let's look at one final example with powers of I. We can get some practice simplifying. Okay, we see a binomial times a binomial. We treat I like a variable, even though it's the number square root of negative 1. So we can use the box method here. Again, to multiply bases, we're adding up their exponents. Okay, so we get a bunch of terms, none of which look like they can be combined right away. So let's deal with each of them individually. I to the 5th is square root of negative 1 to the 5th. That's 2 pairs and a leftover. So these guys cancel, these guys cancel. Here there's nothing to cancel out with, so we get negative 1 times negative 1 times the square root of negative 1. That's positive 1 square root of negative 1, or 1i. Okay, let's deal with this next term. Negative 4 I to the 11th. That'd be negative 4 times the square root of negative 1 to the 11th, if all we're doing is substituting. So we're multiplying this square root of negative 1 by itself 11 times. That'll give us 5 pairs. Plus a leftover. So when we cancel out our inverse operations, that gives us negative 4 times negative 1, negative 1. That gives us 5 negative 1s plus a leftover, which will give us negative 4 times negative 1i, or positive 4i. Okay, our next term to work with is negative 3i to the 4th. This time I'm dealing with each one individually, and then we'll add or subtract them all together. So this is negative 3, excuse me, times the square root of negative 1 to the 4th. We're just substituting I is the square root of negative 1. Split them into pairs. Cancel out your inverse operations. And one more term to deal with. 12i to the 10th. Substitute. Pair. Ten will give us 5 pairs. Cancel inverse operations. Multiply negative 1 times negative 1 5 times will give you negative 1. And then we're simplified. Okay, so we used the box method. Since we're treating I like a variable, we ended up with 4 results, each of which we individually simplified. So we're just adding or subtracting these all together. So originally we had, let's write it here, I to the 5th minus 4i to the 11th minus 3i to the 4th plus 12i to the 10th gave us I to the 5th was 1i. Negative 4i is the same thing as, negative 4i to the 11th gave us 4i. Negative 3i to the 4th just gave us negative 3. And 12i to the 10th gave us negative 12. We have to combine like terms and put in the negative a plus bi format, and we're done.